Good Tuesday morning. Hope you all had a great Memorial Day, a long weekend, and were able to get outside and enjoy the weather, taking some walks. Hopefully, everybody is doing okay as our economy and country slowly gets back to moving forward. I will not say normal because we will never return to where it was, and exactly what is normal, that's a question for a psychology class. We will not deal with that here. This is the first of two videos today, since I didn't post this video yesterday on Monday because it was a holiday, so we have two videos today. This one is going to be reviewing the previous week's work sheet, and then the next one will be the introduction of the new material for this week that is related to the exponents and stuff like that. So you'll see that in the next video. Just a quick word about the worksheet and the assignment and stuff, and just to remind you, when I post these videos, the idea here for this is that you follow along as I correct or do out two or three whatever problems of the previous week's work, and then you go and look at your worksheet and you make the necessary corrections. And you also visit the other problems that I didn't go over, and you in turn review them as well and make any necessary corrections. I then expect you to take a picture of that and then post it up in Google Classroom, or you can send it to me via email or something like that. Take a picture, send it to me through Remind, anything like that. So basically, you're going to send me the worksheet twice. Once from the previous week when you actually just did the worksheet for the first time, and then you're going to take and send me another picture of it after you've made the corrections and stuff after watching the video post for the week of reviewing the previous week's work. Alright, so without further ado, let's get into this. Exponential growth and decay word problems. So remember that these exponential problems all kind of fit this format. F of x is equal to a times b to the t, where b is going to be either some growth or death. So if it is growth, then it changes to something else, and if it's death or decay, it goes to something else. So if it's growth, that b is going to become something that looks like this, where we start with 1, the initial piece, or element, or atom, or person, or whatever it is that we're talking about, and to it we're going to add some sort of rate, and so that it's going to be increasing. Likewise, so this is growth. Likewise, if it is decaying, we're going to start with that 1, and we are going to, or the initial amount, and from that we are going to subtract some percentage in decimal form, and that is going to be our decay. Okay, so these are the two problems, the two models that we're going to be working with as we go through this worksheet, these 4 problems. And speaking of these 4 problems, some of you are probably like, what the heck? 4 problems? I did 10, or whatever number it was. And yes, that was my mistake. Those of you that accessed this worksheet from Google Classroom only ended up with 4 problems. Those of you that accessed the worksheet from the week syllabus, you ended up with a larger worksheet, and that is completely my problem, my fault, and please accept my apologies and grant me forgiveness. The 4 problems that are on this worksheet are also problems on that same sheet, so you should be able to follow along and find them. The numbering of the problems, 1, 2, etc. might be a little bit different, but you should be able to find them. Alright, so let's get into this. The world population in 2000 was approximately 6.08 billion. The annual rate of increase was about 1.25%, and you'll notice that there's a typo here, 1.25, 1.26. It's actually supposed to be 1.26, and I will make that correction so that doesn't happen again either. But 1.2, either way, still the same thing. Find the growth factor for the world population. So that means I'm finding R. So R is typically as a percent. So literally that's just going to be 1.26%. Or if we write it as a decimal, we're going to move that decimal over 1 twice, right? 1, 2. So that means I'm going to have 0 0.0126. Okay? So that's going to be the answer for part A. Suppose the rate of increase continues to be 1.26%. Write a function to model the world population. So it's growth. So I'm using this. So remember that A is our initial amount. Well, that's 6.08 billion. Well, I'm not going to write billion out. I'm just going to write 6.08. And remember in my head that we're actually dealing in the magnitude of billions when I get to my final answer. So then it's 1 plus r. Well, that's going to be 0.0126 to the t. So there is my equation, a function. And I'm just going to simplify that, because why would we leave it all apart, right? So 1.0126 to the t. Okay? So that's the answer. This is the answer for problem number 1. Part A, this is the answer. Oops, I crossed out the t there. For part B, let x be the number of years past, or t, the number of years past the year 2000. Find the world population in 2010. So that means I'm going to take 10 and plug that in here for t. So f of x is equal to 6.08 1.0126 to the 10th power. Okay? So I just do that math-wise, and let me get the calculator up here, and we will look at that. So here's the calculator, and like I said, it's 6.08 parentheses 1.0126 parentheses raised to the 10th power, and enter. And that's going to be 6.89. Now remember, billion. So in other words, 6,890,000,000 people approximately. Okay? So that is going to be the answer for part C. Okay? Hopefully that makes some sense to you. Alright, so like for number 2, it's a decay, so this 9% here is going to be become 0.09, okay, and that's going to be your R, and you're going to subtract that, so 1 minus 0.09, and you're going to set up the equation from there, okay? I'd also like to jump over and take a look at problem number 4, okay? The population of an endangered bird is decreasing at a rate of 0.75% per year. There are currently about 200,000 of these birds. Write a function that models the bird population, and how many birds will there be in 100 years. Okay, so again, here's my A, here's my R. Okay, now pay attention, that's already 0.75%. So it's a decimal in a percent, so we're still going to move that decimal point over 2 spots when I plug that in, okay? So f of x is going to be equal to 200,000, okay, 1, and it's decreasing, so minus, and then it's going to be 0.1, 2, so 2 zeros, 7, 5 to the t. So that's 200. Okay, and then 1 minus 0.0075 is 0.9925 to the t. There's my function. Okay. And now I have to, it tells me 100 years. So I'm going to take this 100, and that's going to come in and plug in here. So f of x, or f at 100 actually, right? As we're plugging 100 in there, is going to be 200,000.9925 to the 100. Okay, and that's what I'm going to plug into my calculator. So let's go back over to the calculator. Let's clear the screen here. And we're going to do 200,000, parentheses 0.9925 parentheses raised to the 100. Okay? And enter. And you'll see that in 100 years, that bird population is going to have decreased from 200,000 down to 94,206. Okay, we can leave off the decimal because it would be really weird seeing 6/10 of a bird. I don't know what that would be like, but yeah, probably not very neat and clean. All right. So those are the review of the 2 problems from the 4. Again, I apologize for the mistake if you access the material from the syllabus. I'll make sure that does not happen this week. If you have any other questions, feel free to ask over Remind. Sign up for office hours. Okay, they're Tuesday and Thursdays, both in the morning and then also in the afternoon. And don't forget, we have our optional Wednesday virtual check-in at 1:30. The invite will be posted in Google Classroom and will also go out on Remind at 1:20. Just to remind you, you can just click on the link. Hope to see you all there. Yeah, all right. Thanks, and stay tuned for the next video.